Okay, students. So as I told you yesterday that today we are going to discuss about two of the experiments. So after experiment number 8, I'm just switching over to experiment number 9, and let me tell you that this is one of the easiest experiment in all of your BTY 106. You need to focus only on one simple technique involved over here and very less requirements over here. So guys, ready for this simplest experiment of your BTY 106? So the name of this experiment is thin layer chromatography for separation of lipid components. See, this is the aim of the experiment. It is also written in your lab manual. And see, separation word I have make it in an inverted comma. Why? Because chromatography is a technique of separating the components. So you need to focus on one thing, that this is the first technique you are going to do for chromatography. You will learn so many number of chromatographic techniques in coming years. So this is the most easiest one, thin layer chromatography, also written as TLC. Okay, so again, I would like to tell you that there are certain requirements. It is also being available in your lab manual. No need to be worried too much. I'm writing it over here PPT on PPT, but you can see it onto the lab manual also. So silica gel is the requirement. If you have seen silica gel in the lab, it is very fine powder like agarose, and it is much more like powder, right? And you need certain solvent system. So the solvent system which you are using over here is a mixture of three things: hexane, diethyl ether, and glacial acetic acid. Let me enlarge it. So here it is hexane, diethyl ether, glacial acetic acid. And what is the ratio? 80 is to 20 is to 1. So 80 ml you will be taking hexane, 20 ml you will be taking diethyl ether, and 1 ml you will be taking glacial acetic acid. So this will be your solvent system you have to make in this ratio. You need iodine. You have used iodine before, that was iodine solution. Here you are going to use iodine crystals. Then you need standards of lipids like cholesterol, like oil sample, whatever you are taking, you need to dissolve it in certain solvent system, because I have already written over here 20 milligram per ml in chloroform if you are taking cholesterol, free fatty acids, triglycerols, etc. If you are taking oil sample, you are going to uh, actually you are going to take 20 milligram per ml in chloroform or hexane. Okay, next thing. So let's talk about technique. So chromatography technique is used to separate non-volatile mixture. You have to find out the identity of that particular component, because there are a mixture of components present in a particular solution. So for example, if you're taking plant extracts, there are so many mixture of it present over there, so you want to separate it, right? So you will be using chromatography technique. Thin layer chromatography is not that complex. It can be performed onto a sheet of glass, onto plastic or aluminium foil. These days we have been so much sophisticated. So on aluminium sheet you got silica gel already incorporated onto it. However, in lab at an initial level, you are going to make silica gel, and you have to make this film of silica gel onto the glass plate or glass slides. Okay, so uh, this layer, when you will be making it, becomes an adsorbent, and it will be acting as a stationary phase. So there are two words in this TLC. One is stationary phase and one is mobile phase. So don't ever forget about it. There are two different, two such components you should always remember: stationary phase SP or mobile phase MP. So the stationary phase that you have prepared is silica gel plate, and mobile phase is the solvent that you have prepared. It means which actually runs in the system. How the mobile phase will be moving up to the stationary phase? It is through the capillary action. It is written over here, last line, capillary method. So if somebody asks how the mobile reaches into the stationary phase, it is through the capillary action. Okay, so procedure, as I told you, to make a silica plate, that is, you just simply have to make a silica slurry. in water and make it very carefully. It's just like 1 is to 2, I mean ratio 1 gram is to 2 is to 2 ml of water. So ratio is 1 is to 2. It's a lump sum, like you can take, if you have an idea of making the plates, you can easily understand that, no need to be weighing and all. So you make a thick slurry of silica in water, and then you have to apply it onto the TLC glass plate. It can be a slide also, you have seen glass slides. Then you have to dry it in room temperature first, and then you have to activate it at 110 degrees centigrade in oven for 30 minutes, or you can use 180 degree also, but let it be for 110 degrees centigrade for 30 minutes, so that it could be activated, because there are fine pores in silica gel, so it gets activated so that sample could move in that pores. Then with the help of a pencil, you have to make a line at a distance of 2 centimeter from the bottom. So आपको bottom से 2 centimeter ऊपर एक line खींचनी with the help of a scale and a pencil. Then you have to apply a lipid sample directly as you have prepared. I told you cholesterol or any oil which is already prepared in some non-polar solvent. So take 3 microliter for a small plate and 5 microliter for a big plate. So if you want to make a very thin line, you can. If you want to make a drop, you can. So either you make a drop, either you make a thin line of that sample, and then you have to keep that slide or to the plate into a tank of mobile phase, where a tank is just like a container, like a beaker. So in that tank you take the solvent and the 80s to 20s to 1 जो ratio में आपने बनाया है, and then keep your slide in that container, and your place of application of sample should be at the bottom side, and from there the solvent will start reaching upwards. So by this, at the end, when you will be taking out the when your solvent is completely run away, so make sure the solvent should not leave the slide out. I mean उसकी last stage से बाहर ना जाए, स्लाइड को एंड तक ना जाए उसके, ठीक है. सो I can say 80% of the slide it should run. You have to remove it from that container, the TLC plate, and put it in a beaker where you have already kept certain iodine crystals. And if you put your slide in that beaker, iodine actually generates fume, right? So in that fume, you will be able to see the spot of your TLC plate. So it will show you a spot of I can say the lipid onto the slide, a silica slide, right? So what you need to do at this stage, you need to measure both the distance traveled by solute, that is your lipid, and the distance traveled by the solvent. So solvent and solute. So suppose your lipid has run 0.6 centimeter, or you can say just I can say 6 centimeter, and your solvent runs the 10 centimeter. So you have to calculate RF value. What is RF value? Retardation factor, distance moved by the sample divided by the distance moved by the solvent. So if your sample has moved 6 centimeter, your solvent have moved 10 centimeter, it is 6 by 10 or 0.6. So it is a good RF value. RF value should never be 0.9 or 1, because if it is coming 1, it means both of them traveled equal distance. These are certain glossaries, just go through this. I'll discuss some more in your tomorrow's class, and at the same time I have a schedule at 11:30 with you all on Zoom video. So you have to click on that link, put that meeting ID and password. I'll be available for your doubt clearing sessions. Thank you. Have a nice day.